So I will start. Hello, everyone. Thank you for joining today's webinar. So this is the third Oper8 webinar. It's focusing on alternative weed control. And today's topic will be robots and robotic, and we'll try to understand what are the key points for a successful uptake by the agricultural sector. So just to start, before handing over to the speakers, I will remind you or explain you what is Oper8 project. So it is mainly a transfer project. The aim is to improve the uptake of alternative weed control solutions, so herbicide-free solutions. And so we've been working on inventorying and assessing the solution. There is a literature review that has been done. Currently, there are communication and technical support being produced. So you have on the website oper8.eu many information, mainly in the news and events for online and local events, such as demonstration events, for example, in the different involved countries. And you also have some resources in the knowledge bank section such as the digital inventory, just gathering all the literature available about alternative solutions. And also we are starting to provide some videos, podcasts about the different solutions. So the countries are involved by sharing what they have done at local scales, such as trials, and we have some feedbacks from different stakeholders through workshops, through different activities, and the idea is to share this knowledge throughout Europe. So just some contact persons. The video is being recorded, so you can have this list later in case you have any questions or if you want to get involved in the project. So for the 7 countries involved, and you have the general project coordinator, who is Olga Crazy, based in Greece, that you can contact also if you have any question. Today's program is now on the screen. So we will start with Vitalis, who will talk about robot prototypes and the general market offers, mainly for field vegetables and horticultural sector. Then we will have one focus on one robot, which is from Farm Trade Company, also for field vegetable and horticultural crops by Rasmus Mikkelsen-Twinsen. And then we will switch to perennial crops with Christophe Gaviglio, giving us some trial results, some key points to use viticulture robots based on experimental projects. And we will finish with a focus on another robot, this time the Vitibot from the Vitibot company, and that will be presented by Luca Cazzola. So just some technical information. If you have any question, you cannot talk, but you can write your question. You have a question section, so just type in your question and we will read out loud. We will try to allow some minutes after each presentation to address your question. And also in the end, we should have some time if you have some late questions coming. And afterwards, you will receive an email from the GoToWebinar platform to give your opinions. You will have a survey that is useful for us to improve and to know which topic you would like to see addressed. And you will also have the link for the recording of the presentation if you want to see it afterwards. So now I will hand over to Vitalis and switch my screen.
Hello, do you hear me? So my name is Vitalis Osičuks. I am a professor and researcher at Latvia University of Life Sciences and Technologies. And today I would like to present a little research and our experience on working on agricultural robots for weed control in horticultural applications. We started about 6 years ago. We had already some experience with mobile robotic platforms and decided to go into this new field for weed control. There are actually a lot of current challenges, and they are remaining the same as from that time, 6 years ago. One thing is the necessity adopt of current farming practices to for robotic solutions. Also, there is a lack of different efficient and meaningful applications at this stage of development. For example, there's a lot of robot startups and pilot projects regarding survey of fields, regarding gathering some information about plants and so on. But actually, farmers are very interested in some real effect on field, like sowing or weed control or fertilizing and so on. Of course, there are also some technical issues regarding data sets gathering and annotating for artificial intelligence training for a robot application. Also, there's a conservativeness of farmers. Farmers are very conservative in choosing of their tools because mainly they are working with money they earn or money they borrow, and they will think twice if to invest into some maybe not ready or in a prototype stage solution for their works. Also, least but not least, is legal aspects of autonomous robots. If you are talking about autonomously moving robot in European Union, then there's a strict regulations regarding of autonomous vehicles, not only on roads, but also, of course, on closer territories like farms. And basically, if a robot is going autonomously all the time, there should be also a supervisor nearby or remotely to work with the robot. And this aspect negates all gains of the robot. In our research, we focused on laser, use of laser for treatment of weeds, and there's a lot of benefits which can be when introducing a laser for weed control. These are well studied in various scientific research and pilot projects. Laser is fast and precise instrument. We know it from industry, where laser used for welding, cutting, and other works, from medicine and so on. This way, laser could be a very good approach and practically the only alternative for hand work when working on weeds, inter-row and inter-crop. And of course, when using a laser, if it is done efficiently enough, we can reduce chemicals for weed control, and also we do not disturb soil and weed seeds as it would be with mechanical weeding. There is also a lot of conditions for efficient laser use. One is safety, configuration of rows, and also there's a lot of requirements regarding platform or tractor moving precision, height adjustments, and so on. When considering laser for use in weed applications, we need to think about how we will apply the laser energy to weeds. One thing is selecting right type of laser, and another thing is how we apply this limited laser energy to plants. When we are talking about plant, a green leaf will absorb certain wavelengths of electromagnetic spectrum. Here is a visible light spectrum, and I have also added at the bottom part of the chart two common types of commercially available lasers: semiconductor laser and neodymium YAG laser. And we can see that laser working at a very narrow wavelength will affect leaves with changing efficiency. If we are working on a blue light spectrum obviously will work better than on green light because leaves are greens, they are reflecting green light, but blue light, red light is absorbed, and obviously it is better to work with such kind of lasers. If we see a little bit farther in electromagnetic spectrum, then we can not only work with chemicals in leaves like chlorophyll, but also with water. And I mean by evaporating water. And this for this purpose, one of the best solution is CO2 laser, which is a very mature technology. Works at about 10 micrometers wavelength and allows to evaporate water. During our developments, we worked on a robotic platform which could bring a laser and some mechanical weeding tool on the field and make field tests. This platform is actually based on a mobile robot as a platform developed in our university and consists of off-the-shelf CNC mechanisms which can position effector tools, laser, and mechanical mill. And software part of this solution consists a lot of subsystems. We can see them here, and we can see that from one point of view, this is a very simple device, just a moving platform with two common CNCs, 3 axes. But from other hand, it is a very complex software solution. So here we can see more detail as the hardware part. Before going to field, we made some experiments in laboratory. We used a robotic manipulator and laser. You can see here on the right-hand side. We tested different approaches for treatment, beginning from different use of patterns and use of treatment repetitions. For example, here we can see experiments with 2 treatments. The top row shows control group where plants were developing normally, and we have a constant increase in so-called green mass or the green pixels from picture. And the bottom row shows 2 treatments. Here we can clearly see that plants are keeping the development, and the total green mass area is greatly reduced. By this experiment, we concluded that laser can be used not only to completely eliminate weeds, which takes time, takes a lot of energy, but we can try to reduce the total biomass of weeds, so crops could take over, and we can use laser more efficiency and, for example, increase the speed of treatment. The next stage was, after the project was a startup, we continued the development of laser treatment equipment. And here we moved to a little bit different way, taking into consideration that conservativeness of farmers I mentioned at the beginning of the presentation. So we made a commercial tractor implement with installed laser modules. The implement uses 3 to 4 laser modules. They can be seen beneath the implement and the position 8. Also, it takes energy from PTU of tractor, and it needs a lot of energy. Each laser module takes about 1 kilowatt of power, electrical power, and we use a generator from PTO. Here you can see the main characteristics of the implement. working speed is up to 1.2 kilometers per hour, depending on weed density. If weed density is too high, then we need to decrease the working speed. We had different field trials with simple laser units on a trolley, and then a unit on a frame, and went to the final solution to the tractor implement. We started from lab test. Here I compiled a video of a lab test with carrots and some weeds, and frames with laser light were removed, so it could be see something, because when we are working with a blue light laser, then everything is overexposed and it is hard to see something. And next, a lab test with trolley. Here you can see all the frames, also with the blue light. The working speed is quite high, but as already mentioned, the plants are not completely burned down. We are trying to work only with surface of the plant to reduce its further development and reduce total green mass. And the effect can be seen here in field trials. We can see that plants mainly are not completely eliminated, but the development is greatly reduced. There's a summary of the results with some statistics. And here are some examples of fully treated weeds when working at lower speeds, and some development of treated weed after a week and 4 weeks after treatment, and some partially treated weeds, especially those which are out of our treatment range, large or multi-year weeds. And for main conclusions is that theoretically and practically blue laser is capable of significantly reducing weed development in real conditions, and it is possible to perform weed control by even stopping weed growth and completely destroying its canopy. And it is more feasible also to identify crop between weeds and treat also the green canopies than trying to make data sets for all possible weed species we faced on field. This is regarding data sets I mentioned at the beginning of the presentation. And also, when practically working with mobile robot, localization of it's by using some GNSS technology like GPS in real conditions close to farms is possible, but problems may arise due to close obstacles, for example, buildings, lighting, masts, and so on. So thanks for the attention. Maybe there are some questions.
Thanks a lot, Vitalis. So yeah, there is one question. The question is, how much area could be covered in a day, assuming the 1.2 kilometers per hour speed?
With the implement shown, which is 4 meter, 2 meter wide with 4 laser units, it's about 1 hectare per day, per 8 working hours.
Okay, thank you.
Currently, we are focusing on carrots, and the speed is about 1 hectare per day for that implement.
Okay, for now we have, just one other question that arrived. Did you find differences between dicotyledons and grasses in terms of efficacy? So about kind of weeds.
You mean
between the
different types of weeds?
Yeah, is there a difference between different kind of weeds, such as grasses on one side and dicots in the other one, for the efficiency of the laser technology?
As I tried to demonstrate with pictures, with photographs, as we are not focusing on completely destroying the weed, then of course laser would be more efficient with the weeds which are not with very heavy root system.
Okay,
and there's a last question.
With weeds. And theoretically, we cannot put a laser into unprepared field where weeds are not somehow treated before, if weeds are too large, for example, more than some 5 centimeters in diameter of visible canopy, then there could be a problem with laser at the current stage of development.
Okay, so it would be for early stages with small root systems. Okay.
Yes, of course. Theoretically, if we had a higher power laser, then we could work with with larger weeds, or we could do this by reducing working speed. But then there will no, we will lose the economic effect of the laser.
Okay, thanks a lot. And there is one last question. What about energy consumption, average energy consumption per square meter, or maybe per hectare?
This implement takes continuously approximately 3 to 4 kilowatts of power from tractor, and we can then calculate depending on working hours how much energy we will need. For example, for 8 years, for a hectare, for 8 hours day, for a hectare it would be approximately 32 kilowatt hours.
Okay, thank you. So next is Rasmus. So you're already sharing your screen, yeah?
Yes, I'm sharing my screen. I'll just make it big. So you see my screen?
Yeah.
Okay.
Yes.
Thank you. My name is Rasmus Thusen, and I'm a regional sales manager at FarmDroid. First of all, I'll introduce you a bit to the FarmDroid, what it is and what it's capable at, and how we got here where we are today. So the FarmDroid is an autonomous vehicle. It's 100% electric, powered by the sun, more or less. It's have solar panels on the top, so it charges itself during the day, and have a battery pack that means it can drive 24 hours a day. First of all, we started many years ago with the development, and I just have a small video here where you can see actually where we started, and the idea was that we needed to seed a seed really on a specific spot, because we are only using GPS technology. We don't use any camera at all. So the idea was to start by developing a seeding system that could do really precise seeding and with a high accuracy, and then and after that we could start doing the weeding. So just to get some numbers on, in 2018, FarmDroid as a company was established, and just jump to 2020, where we started to sell the commercial robots, not only in Denmark, where we are from, but also in Sweden, in Germany, in the Netherlands, and Switzerland and Austria. went quite fast in the beginning, so I just jump 2 years more, and then we have expanded our sales to more or less the rest of Europe, France, Spain, but also UK, Norway, and also Canada. And a little bit the same if I jump 2 more years. We now are in both Australia and the US and the Baltics is also and some of Eastern Europe. So we are now covering a big part of Europe and also a lot of other countries. But what do we do? The problem about especially organic farming is weed control. So like we see here, there is insufficient weed control in one side, and then we have another field where we had a farm droid to do the weed control. And this is a huge difference between the two fields, and definitely also something that you could be measured on the yield. The farmers in general, or the social challenge is we do need to have some kind of food security if we are thinking for the future as well. So maybe farming robots could be something that could help out on that. The demographics in general is that the farmers are getting older and older, and we are having less farmers compared to the year before. So in that case, we can maybe implement some farming robots into the farming, and by that achieve the same production capacity. There's also a demand for more organic production all around Europe. There is some plans that we should reduce, not reduce, we should increase to 50% of organic production by 2030. And at least in the end, we have the environment where we also do need to reduce the usage of chemicals and pesticides also by 2030. And for the customer's point of view, I just took some numbers here. It's a case from some organic farmers where we have tried to put down the numbers. There is, I just need to say, if we have an organic farmer, he probably needs to do some kind of hand weeding to prevent the weeds by taking over. So if he invests in a farming robot, he will save a lot of time by the hand weeding. It's also shown in the numbers that they are gaining in yield because that they are getting, let's say, sufficient weed control. And we have some farmers who have up to 40% of increasing their yield. The next part is the labor, because if you have a farming robot or farm droid to do your weed control, you can save a lot in labor, and it's definitely in these days it can be quite hard to at least get people to do hand weeding, not because that nobody wants the job, but there simply isn't any people to get. It's really a big job to do this. So you do save a lot of labor. And then in the end of that, all these people who should do the hand weeding, they also need to earn some money on it. But if you skip these people, you have some money to do the investment of the farming robot. So in some cases, we actually see a return of investment in more or less a year. But how is the farm droid today? The farm droid, it's autonomous robot with ultra high precision. As I mentioned before, it's equipped with solar panels and a battery pack, which is charging up during the day, and then during the night it takes the power from the battery. It's a lightweight machine, so its weight around 900 kilograms, and it's a slow going machine. The maximum speed is 950 meters per hour, which also means that it's allowed to run autonomously in the fields. And then it can be set in different configurations depending on what kind of row distance you need, and depending on what kind of crop you are growing with the machine. As you see on the picture below, all the plants are seated at the exact GPS spot where we want it to be, which means that you can actually see the row lines no matter what angle you're looking at. With the droid, there's also coming an app, and that's actually where the user can monitor what the droid is doing right now, and if there should be any errors or information the farmer will need or the user will need, they will get a notification by that, and then they can go out and check it. And how do we do it? We are using an RTK signal. We are using our own GPS, closed GPS system, which gives us an accuracy down to 8 millimeters. And we do that by installing a base station at the farm or somewhere where we can place an antenna. What we need is just clear view to the sky, and then we can cover 10 kilometers in radius from that point. And as you see on the little drawing here, we are actually doing a boundary around the field, which is a geofence, and make sure that the robot can't drive out of that geofence. If there is any obstacles inside the field, we also mark them out. And when all this is done, then the droid will create a pattern and already have a plan where to seed each seed when it's seeding. I'll just show you a small video here of the weeding part. Now we have limited time here, so I just skip the seeding and go directly to the weeding. I'll just start it up here and I can speak a little. Meanwhile, as you see, the droid is weeding both in row but also intra row in between the plants. And it's all doing this by GPS. There is no camera attached on the machine, so it's know from when it seeded the crop where it had placed every seeds, and by that it weeds inside and outside the row. We are working real shallow, so when we are, let's say, when we're doing the hoeing, it's we only driving in 1 to 2 centimeters of depth to make sure that that we only are touching the smaller weeds. We aim to fight the small weeds because it's easier and also more efficient. And then the machine is just going to drive in the field, let's say more or less 1 time per week. That is our target. And it can cover, there was a question before how much it can cover, and we say normally that a farm droid is taking care of between 20 to 30 hectares. That is the capacity. And normally we also say out to our customer, if we can seed it, we can weed it, because we actually have different ways of seeding methods. One is single out, which could be, for instance, here beets. We can also do portions. We do that a lot with onions, so group seeding, or we can do it in line seedings. That could be, for instance, oilseed rape or herbs or whatever. But if we go look down to some numbers from 22, then we had 50% of our machines were doing sugar beets, 20% in onion, and 30% in mixed crops, various crops. And what crop do we do? I have here some examples: sugar beet, parsley, red beet, onion, turnips, rapeseed, coriander, or kale. But the list is really long. I think we have more than 50 different crops we are doing right now. And every time a farmer has a request for a seed that we might didn't do before, or just want to check up to get the correct seeding discs, then they can send in a seed sample to our seed lab. We normally do this during the winter, and then we test the seed and find out the exact seeding disc he needs for his crop, and then we can ship some seeding disc out, and they will be ready for the spring. That's about it. So maybe somebody have some questions. I'll be open to answer them.
Thank you, Rasmus. So I can see someone is writing maybe, so please write it in the chat. So yeah, I can see there is one. How mechanical parts endure on hard soil, for example, clay.
Yeah, we do have the farm droid is working right now more or less all over the world, as you saw on the map earlier. So we also do have many different soil types. So we do have heavy clay, stony soils, but also sandy soils, of course. And of course, if you have a lot of stone in the soil, it is definitely harder. There's more wear on the parts than there is on the sandy soil. And hard soil, hard clay, of course, it's a lightweight machine, so it needs some preparation of the soil before it can seed. But as long as we continue working during the season and it don't dry out, until now we don't. Until now we can handle these soils. Yes.
Okay, thank you. We had another question. So someone is asking, can you elaborate on the weed control in mixed crop intercropping? Do you have more limitations, for example?
As it is today, we can only, of course, we can seed different crops in each row if we want that, but all rows are, let's say, treated the same way. So if it's single seeded out, it would need to be that in every row. Or if it's line seeded, we can also, of course, you can mix the crops, but it's not something we have much experience with at the moment. But it's something we definitely look into the future, because mixed crops is something also when we're looking at the more environment friendly way of doing things, that's the way to go.
Thank you. So we can see there are no more questions, I think, for now. So if you have, for the audience, other questions about these topics, you can still write it and we will read it later. So thanks a lot, Rasmus and Vitalis, for this part. We will now switch to perennial crops and we will start with Christophe, focusing on viticulture robot trials.
Yes, thank you, Camille. Good morning, everyone. I guess you see my screen now. Let me first introduce myself. I'm Christophe Gaviglio. I'm working at the French Institute for Viticulture and Wine, and I'm in charge of mechanization issues and alternatives to herbicides. So at IFV, we've been working on robotics in the vineyard since 2016. So a lot of time now. And we have had some robots in our fields, and we have had the chance to assess their performance in order to be able to give accurate information to wine growers or to advisors. During this webinar, I'm going to show you a few different robots. So you can see a panel of robots used in the vineyard. I'm going to explain also why we are so interested in robotics in viticulture. And I'll explain also to you how we assess their performance, and I'll give you some figures about their actual performance. Okay, let's start with why we are using robots in the vineyard. More or less, it's the same thing as Rasmus said earlier. the first alternative to herbicides in the vineyard when it comes to weeding under the row between the vines is mechanical weeding. And mechanical weeding as an alternative to herbicide has some disadvantages: a lower efficiency, a short lasting effect, so it requires a lot of time. It requires a lot of accuracy to be able to do the weeding perfectly between the vines without being harmful to the vines. And we know that today we have a lack of qualified tractor drivers, and this is a problem to do mechanical weeding with the tractors. So weeding robots seems to be a very good solution to this main issue of using mechanical weeding as an alternative to herbicides. So let's start with the different conceptions of vineyard robots. As you will see, there are many different sizes, many different conceptions for a vineyard robot. The difference might come from the power source also, and if the tractor or the robot is a straddle robot or an inter-row robot. Here you can see a CTR robot, which is here presented as a straddle robot, but which can also be used in the inter-row, thanks to the possibility to vary the width of the machine. Here we have the VT-Bot Bacchus robot, which is a straddle and electric. On the picture on the right, you can observe why it is interesting to have a straddle robot due to the position of the tillage tools that work between the vines. It is more accurate, more precise to work with both tools on the same row, whereas if you are in the inter-row, you have a space on the left and on the right. Another straddle robot is the TED Nanotechnology one. Here, as you can see, everything is mechanical as it comes to the tools. So electric straddle robot with passive tools. So everything depends on the accuracy of the position given by the GPS. This one is a straddle robot too. It is the one from Exact Robotics. Its name is Trax, and this one is a thermic machine, so with a traditional engine inside, which is considered as a good thing from many viticulturists, because they find what they already know, whereas an electric robot can be considered as new and very innovative, and can sometimes afraid new users of the robots. Let's move to the inter-row robots with a nanotechnology Joe machine. In this configuration, you can see that the weeding, mechanical weeding, can also be in the inter-row. You can see that this machine is very compact and very lightweight, like many other robots that you can see in viticulture, which is an advantage compared to traditional tractors in terms of soil compaction. The last one, which is, as it stands on the picture, a prototype from a green culture with another tool designed to management, even if it's not yet weeding under the row. It's soil management in the interrow, and especially crop management. This one is a hybrid too. So how do we assess the performance of this kind of vineyard robots? We have to tackle a few challenges, like the length of the row, the slope, the kind of soil, the kind of tools being used, which all have an impact on the performance. The performance that can be defined by the surface that can be managed through the year by a robot, the energy being used, and the reliability. About the surface, we have to take into account the time taken for a U-turn, the length of the row, and the actual speed while working with the tools. We can add also the time of transportation between the field, which is an issue in some vineyards. So here is the range of results that we have with today's robots, and we know that these results might change a lot in the future years because everything is going so fast now in the sector of robots in viticulture. But today what we have an actual working speed around 3 to 4 kilometers per hour, which is not bad. Robots could work much faster, I think, but there are security issues. So maybe the working speed should stay around 4 to 5 kilometers per hour. The U-turns time goes from 16 seconds to around 1 minute per U-turn, depending on the model, depending on how the U-turn is made, depending on the weight of the space between the parcels, and how the U-turn can be defined in the map. But it's quite good, and this has an impact only with very short rows, because the longer the rows are, the less impact the U-turns have. We also have to take into account the occurrence of unwanted shutdowns, and in all of our trials, this represents only 10% of the total usage time in the field. So this leads to these figures for white vineyards: 2.5 hours per hectare in white vineyards, so more than 2 meters width between the row, and in narrow vineyards around 6 hours per hectare. This is for today's performance as it stands now, and we have also assessed the energy consumptions of the robots for electric robots only, because when they are hybrid or thermic, it's quite different. But with the electric mode only, we have assessed good performance of 5 kilowatt-hour per hectare, which is very low compared to the use of a tractor. A tractor consumes at least 5 liters of fuel per hectare doing the same job, and in 1 liter of fuel you have 9 to 10 kilowatt-hours. So it means a difference from 1 to 10 in terms of pure energy used in the vineyard. Let me finish with some thoughts about the challenges that are to be targeted for growth of the robotics sector in the vineyard. The third challenge to be tackled is the price, because we are okay to say, yes, robots are great, they're working quite good, they're efficient, this is time saving for the users, this is energy saving, they are accurate, and most of them are a lightweight solution, which is good when you think of compaction issues, but still they are a little bit expensive for most vine growers, at least in France. Challenge number 2 is security. Could be challenge number 1, but anyway, security is very important to tackle, because it shouldn't be a limit to the performance, I mean to the speed of the robot. And the more sensors you add, the more security you had on the robots, the more developments you had, means the price will increase. So we have to find very efficient security solutions without being too expensive. Challenge number 3 is the transportation of the robot between the fields and the user supervision, which is linked to the security challenge. But I won't talk too much about all this, because for the end of this webinar, we have the last speaker that will talk about a very, very effective robot. Thank you for your attention.
Thank you, Christophe. So before handing over to Luca, we can take some questions. For now, there are no questions for viticulture, but in between we had a question for Rasmus, so we can maybe read it now. So Rasmus, the question is, can the farm droid work on high ridges, for example, in carrots or potatoes?
Unfortunately not. We can do some. We have a 4-wheel version that are working on a bed system that some veg producers are using in, for instance, onions, but we can't. It needs to be lower beds or flat beds, whatever you call it. But ridges and especially carrots is not something we are good at, because our minimum seed, our row distance is 22.5. And the carrots are normally seeded in a double or triple row system, which we can't achieve today, unfortunately.
Okay, thank you, Rasmus. So we can take, if you have other questions about viticulture, otherwise you can write it and we will read it in the end of the presentations. So no more questions for now. So we can maybe hand over to Luca, and feel free to write any question you have. Thanks, Christophe.
Hello, everybody. I hope you can see the screen.
Yes,
okay. So first of all, I'd like to present myself. I'm Luca Cazzola. I'm a sales manager for the Italian market of Vitibot, the French manufacturer of the robot Bacchus. Before starting, I'd like just to give you an idea of what is the mission of Vitibot. We already mentioned in the other speakers already mentioned these challenges. Vitibot has the goal to give a concrete and practical answer and solution to the challenges that vine growers are facing today. In particular, the environmental challenge, if we think about it, it's required to produce, like society requires vine growers to produce in a more sustainable way. Let's think about the regulatory pressure on the usage of chemicals for the weeding. So like this forces vine growers to use solutions such as tractors for mechanical weeding, and so to use much more machines and much more manpower. So automatization of these tasks is very useful. Let's think of the societal challenge. Like in particular, there is more and more a lack of manpower, and not only a lack, but when you find also the personnel, the people to work in the vineyard, is often very challenging to find specialized ones, or people that will stay because they will switch to another job because to them maybe it's too hard. So to propose a solution that is a robot, it's gives much more attractiveness, especially to young people to come to work in the vineyard. And last but not least, the economical challenge. So like the costs of fuel are skyrocketing. In particular, also the cost of maintenance of traditional machines. So VTBot brings to the market a solution that is totally and fully electrical and address like in a practical way this challenge too. So before starting to talk about the robots, about Bacchus, I'd like just to give a very brief presentation of who is VTBot, to give you a bit of context and background. So VTBot is a French industrial company that started from a project for the university of from an engineer from Champagne, a son of a vine grower in the Champagne region in France. And he started by automatizing by putting a GPS antenna of on an existing inter-row diesel tractor, one Caterpillar tractor, like the ones that you can use in very narrow vines, like 1 meter, 1 meter 20, for example, as it is in the Champagne area. From this project, the VTBot was founded. It was founded and thanks to investors such as like big Champagne also companies, big like wineries, and it kept developing the product until today, where we have the final version that is the Bacchus that we commercialize today. So we're not anymore in a prototype stage. It's a fully operational machine, and VTBot today became part also of Samedoitsfar Group, which is the same group that owns the brand of harvesting machines Gregoire. So like it's one of the most specialized groups in manufacturing of tractors for specialty crops such as vineyards. So today VTBot is an 80 employees company. Based the facility is based in Reims in Champagne and has a branch in Bordeaux. And we are present in over 7 countries, mostly France and Italy, and we have a fleet of more than 150 robots operating in the vineyards today in the world. So to switch to Bacchus, today VTBot produces 2 models of robots, the two model of Bacchus, the model S and the model L. Both are electrical, both have the same performance, and the only difference is the dimension. The L model can go on a large vineyard of with posts that are up to 2.2 meters, and a canopy width of 80 centimeters, and the small version is more for the narrow vineyards, so from 90 centimeters inter-row space and with posts up to 1.75 meters and 60 centimeters of canopy width. I'd like to show you a video before explaining more in detail how the machine works. So here you can see the 2 models in the video, the large and the small one. Performing in this case mechanical weeding with several tools. We will see in the detail later how they what type of tools you can mount on these machines. The guidance, the GPS navigation is through so the autonomous driving it's done totally through GPS with RTK connection. The vineyards have to be mapped before, so like once the mapping is done, the machine can operate, do the U-turns like you're seeing here. Everything in totally in an automatic way. So like the machines need just this mapping at the beginning, and then they can perform the job autonomously. Here, as I was saying, in terms of performance, the machines are fully electrical, meaning they have 4 motors in the wheels connected to 4 batteries of 75 kilowatt capacity, which allow me an autonomy of work that goes from 10 to 12 hours. This is possible thanks to our electrical tools that you will see later. The machines can go to up to 45% slope, 20% lateral slope, and need only 4 meters thanks to the possibility to turn on themselves in the U-turn space. So what can Bacchus do? Bacchus is a machine that is born for mechanical weeding. So the main job is, of course, to kill the weeds between the vines, and it can do it with several type of tools. The particularity of VTBot is that we have electrical tools such as electrical intervine, or the electrical flail mower, and this will allow us to be very performant in terms of energy consumption, because the motor of the electrical tool is very well suited and compatible with the electrical motors of VTBot. So this allows me to work many hours, and this is like for a robotic and automatic solution is very good. But you can also mount all mechanical tools that you are that the vine growers are already used to, that already have in their let's say in their company. So this is also a great benefit for them, because they can use something that they already have, not the hydraulic one, of course, but the mechanical to make like here you can see an example of mix of electrical tools, flail mower and electrical intervine, and mechanical tool to perform mechanical weeding in the vineyards. Of course, we don't want to give a solution that only does this, but we want a 360 degrees solution. So we are developing other tools such as like sprayers, trimmer, pre-pruner, sucker remover, a leaf stripper. Like you have several types of tools that will be available soon in the market. So not only mechanical weeding, and the particularity still is that Bacchus mounts only electrical type of tools, so it's not hydraulic, and this will allow me to have a very good autonomy in the vineyard maintenance job, unlike other solutions that claim that they can, you know, mount other tools, but this will eat their autonomy literally. So we can, thanks to electrification, we can have a very good performance. So how does the machine work? As I was mentioning to you before, you need to do a mapping at the beginning. When a customer buys the machine, we do a mapping of all the rows, so the perimeter, like the borders of the plots that he wants to work, and all the rows. After that, the machine can work autonomously. It means that you can bring the machine on the vineyard on the first row. You will do the settings through a smartphone that is provided with the machine. So you will tell the machine what it can, what type of operation do you want it to do. Give all the settings, and then you launch the autonomous mode, and the machine can work autonomously. So once the machine is working autonomously, you have like all the machines are supervised. I mean, this is not mandatory in terms of this remote supervision. When for the machine to operate, it can operate even if the supervision is not available. The supervision is basically a team of technicians. I will show you here that are based in Reims, and they can see what the machines are doing. So they can see even a 3D model of the machines. They can see the entire fleet that there is in the world. They can see a lot of parameters, and they can even call you if there is some problem. They can see it through live cameras. So it's very convenient for the vine grower, and it's very reassuring for them. Like they can really feel like since it's a new technology, you know, sometimes you might need some support from distance, and this is very useful for them. And it's very important, and it's very particular to VTBot. this type of remote supervision made by the manufacturer is not going to stay only in the manufacturer. Of course, the manufacturer will be able to do some particular things that the customer won't be able to do from remote, but it will be available also very soon to the vine grower that can check already many things from his smartphone and from his computer, but he will be able to see even much more things. So thank you for your attention. I hope I've been in the time that, and if you have some questions, of course I'm here to answer them.
Okay, thank you,
We
Luca.
have sorry.
Yeah, go on, Emma. Go on.
We've got one question here for you, Luca. When you say electrical tools, do you mean electrical weeding?
No, I mean tools that work with electrical energy. So like, for example, the electrical intervine. So it's a machine, it basically works like the hydraulic one, just it's not with hydraulic motor, it has an electric motor. So the efficiency of the tool is much higher, but it's not electrical in terms, we're not like killing the weed with electricity. We are just giving the energy supply through electricity, through an electrical motor, but not hydraulic one. I don't know if that was the question.
Yeah, I think that was a question. Yeah, thank you. Another question to both Christophe and Luca. How easy is to adapt these technologies to other types of perennial crops, such as apple, kiwi, berry bushes, or?
So since we are, the Bacchus was developed for vineyards, so it's it works very well on vineyards. We have some experience with olive trees, the small ones in particular, the super intensive system of cultivation, but we do not have any other, so far at least. I think like I don't think it's because maybe every crop has different necessity. We had some questions, of course, some demand from other crops such as berries, also in the Netherlands, for example. But we, at least I've never tried on these crops. I think that even if the principle is the same, it might be the biggest challenge today might be also probably the cost. Maybe the vineyard has more added value in the production than these other crops. So maybe that's also one of the challenges. It's not just physical challenge. Maybe it's also like for the investment for these type of crops.
Okay, thank you. Still about maybe Christophe, do you have something to add about other perennial crops?
No, nothing special to add. Just the main problem is the height and the weight of the crops. So in our cards, it won't be easy to use straddle robots. Maybe inter-row robots in the future. Maybe.
Would be, yeah, shared. Okay. About Vitibot, does it go to a docking station to charge?
No, not so far. Mostly, I'd say for safety reasons, because still you have machines that, of course, they have safety sensors. So when they work autonomously and they move autonomously, they detect people, so it's very safe to operate around the machine. But still, it's our engineers wouldn't so far at least allow the machine to go autonomously somewhere on a big distance. But yeah, I don't know if maybe it will be developed in the future. So far, you have to bring the machines to the field.
Thank you. And how many machines can be supervised by one person?
So today we give one phone and one emergency stop button, so per machine. So in theory, you should have like one person that supervise one machine, but for sure, I mean, if you can maybe hold two devices, you can maybe supervise two. I'd say one machine can cover many hectares, so like you might have not be able to supervise two machines in the same time, but because of the distance.
Okay. We have one question back to Rasmus for FarmDroid. With the solar charging system, does it still work well in very cloudy conditions on, I guess, many days?
Yeah. Yes, it does, but of course it don't charge as much as it do on a sunny day. Our solar panels are in total 1.6 kilowatt, and depending if you have the standard battery pack or you have our power bank, which is, let's say, a double up, and if you have our power bank, that is what we recommend, especially in depending where in the world you are. But if you're working really, let's say, early spring, it could be February or March, or late in the autumn, we always recommend to have the extra battery pack, because this power bank, you can actually take them off and charge them during the day while it's just running on the standard batteries, and it will also charge them by the solar panels, but then you can by evening you can put them back, so just to keep the machine running as much as possible. But yes, to answer the question, it's on a cloudy day it might only charge between 100 and 500 kilowatt per hour, and the usage of the machine, it would normally be around 400 to 600 watts per hour. So yeah, that would be the answer.
Okay, thank you. We can take some more questions if you want to write it. Just maybe a general question about the feedback of your farmers. Do you know if they are having mixed strategies, like maybe using herbicides at some point and then switching to their robots, or are they 100% depending on robots when they have it? How do they work?
Was that a question for me?
The two of you, or even yeah, the two
I know
of
at least
Rasmus and Luca. Yeah.
I know at least from our customer side, we do have mainly organic farmers, but we also do have more and more conventional farmers who are combining the best of the mechanical weeding and with the sprayer. So maybe if, let's say, in a standard situation, they spray 4 to 6 times per year, and then they might only spray 2 times instead. It depending a little bit. We also did this year. We entered the market with a spot spraying system that we can mount on our robot to do the spot spraying during the operation, where we combine the mechanical weeding and the spraying to save some chemicals. I don't know if Luca has anything to add.
Yeah, I'd say it's more or less the same. Like at least for my customers here in Italy, I see that they use it can happen, yeah, that they use both solutions, like they do spraying with the tractor and then use the robots for the mechanical work. But I'd say that most of them try to, once they get a robot, they delegate completely the weeding to the management to the robots. So like it's because it's very effective, and they like usually they want to keep like to do like this, like unless they have very many hectares, so they can't manage, but usually they delegate most of the job to the robot. I mean, or all of the job of the mechanical weeding.
Okay, thank you. Luca, did you talk about how many hectares is well adapted to one robot? Did you have some numbers about that?
So it really depends. Since we are a multi-purpose, we have a multi-purpose robot. I would say that, and it depends also. So it depends on what tasks do you want the machine to perform, if only mechanical weeding, or you want it to do also, you know, trimming, spraying, or other things that it can do. It depends on the inter-row space that you have in the vineyard. The narrower, of course, the less space, the less hectares it can cover. But I would say that on average, one machine, depending on the usage that you do, can go from 25, can manage from 25 hectares to up to 100, maybe, depending on the inter-row. Depending on the, like, large vineyards can go, let's say large vineyard, one operation, so mechanical weeding, you can go 100 hectares, I think, easily, because we have these examples in Italy. Several operations, meaning that you have to, you know, do the trimming, then you change the tool, put the other one, like maybe 30 hectares, 40, it depends. Like similar to a tractor, when you make it do everything, like, so a tractor, usually we are around 20, 25 hectares in Italy. I don't know about the narrower the vines, probably in France is, of course, this number might be different, but in Italy, I'd say that yeah, roughly, like I said, between 25 and 100, depending on the operations and depending on the inter-row.
Okay, thanks a lot. So I see there are no more questions. So I think that will be it for today. Thanks a lot to our 4 speakers. Thanks to Emma for organizing, managing the platform. So just to remind you, you will have the recording later, and please, if you have some time, answer the survey. It will be useful for us for the next webinars. And thank you for attending this webinar.
Thank you.
Thank you. Bye.
Thank you.
Bye.
Bye bye.
Single bye.